introduction to Axum. First, who am I? My name is David. I'm here from Copenhagen. I am the creator and maintainer of Axum. As part of the Tokyo core team. By day, I make games at Embark Studios, a company in Stockholm. And that's my Twitter handle, my last name. Remove all the vowels, and there you go. If there's any questions at any point, just raise your hand and shout out. We don't have to wait until the end. So what is this Axum thing? Well, it's a web framework that's made by the people that brought you Tokyo. 0.1 came out almost a year ago, and we're currently up to version 0.5, which came out in March. 0.510 as of yesterday. It's very much sort of a micro framework in the same sense that like Warp or Actix or Tile or Rocket, maybe not Rocket, that has a slightly bigger scope, but it's sort of in that realm. So we're not at Rails or like Django size yet. I definitely want to say that even though we're not 1.0 yet, it is production ready. Part of the reason is that we try to not invent, we'll try to invent as little as possible, I would say. So we're sort of standing on the shoulders of giants. Obviously Tokyo is the runtime, Hyper is the HTTP implementation, and then Tower is this middleware service library that sort of glues all the pieces together. We have over 5,000 stars on GitHub, and as of last week, we have more recent downloads on Crates.io than Actix Web, which is sort of mind-blowing. I don't know if that's how you measure popularity or whatever, but it's pretty cool, I gotta say. The sort of high-level, like tentpole features, if you will, is that you can route to requests with a macro-free API. You can declare it with parse requests using extractors. There's a simple and predictable error handling model. Generate responses with minimal boilerplate. And you can take full advantage of the Tower and Tower HTTP ecosystem of middleware services and utilities. It's not marketing speak, but it's like borderline. I'll show you throughout the talk what exactly I mean by all these 5 things. First up, this is sort of what the hello world looks like. Regular Tokyo main, you make a router, some address, port, whatever you want to bind to, called Axum server. That's actually just a re-export of Hyper's server. So Axum doesn't even need its own server built in. It's just any server that handles the Tower middleware. Those just work. Say app.yourrouter.into make service. Don't need to worry about what that means. That's sort of a Hyper Tower specific thing. Thought I'd wait, and now you're receiving requests. There's not a lot of boilerplate to sort of get started. Routing is probably the first thing that you would want the web framework to do. You make a router, you call .route, you give it the path that you want to match, and then whatever the second argument is, that's anything that implements the Tower service trait. So Axum has sort of a DSL for you to build services. So get will make basically a mini router that routes based on the HTTP method. In this case, get only accepts GET requests. And then root is a handler function. We'll get back to what that means. You can obviously also say like /users. In this case, we accept both get and post. Those go to different handlers. You can write a colon in front of one of your URL segments, and then it becomes a path parameter. Later, we'll see how you get those out again and get the actual values. And lastly, you can do a wildcard with a star. So then the star tree will match any number of URL segments, basically, with all the slashes. So if you were building like GitHub, where you wanted like a file path in the URL, you could do something like that. There's some APIs that allow you to sort of decompose and merge routers in different ways. One of them is merge. So we can write like one router separately, return from a function, put a different module, get it from a library, whatever, and then just say .merge, and then we'll effectively get the sort of combination of all the routes. You can also do nesting. So in this case, we make a router that we just call API. It only accepts /users. And then at the bottom there, we say /API. So we nest the API at /API. And then the final route will effectively become /API/users. So it just sort of appends that prefix to all the other routes. And lastly, you can do a fallback. So that's just if there's no route that matches the request that comes in, then the fallback is called. Pretty standard stuff. Handlers. So handlers are these things that we provided to the get and the post function that we saw earlier. And it's just a standard Rust function that has to implement a special trait. In order for it to do that, it has to be an async function. It has to take 0 or more extractors as arguments. And it has to return something that implements the into response trait. Here's an example of a handler. So you can think sort of as extractors as dependency injection almost, but sort of pulling like parts out from the request. So obviously we can get the request method, the URI, and the headers from the request. They're sort of directly there. String turns into response. So this thing implements the handler trait, and then you can give it to get at the bottom there, and then Axum sort of knows how to wire all that up. And you don't need any macros. Cool. What's an extractor? Well, an extractor is any type that implements this trait, basically. It's called from request. It has a single method. It takes the request parts, which is basically a type in Axum that just sort of wraps up a request and has a slightly constrained API that allows us to enforce certain invariants. And then it returns either a value of type self, so in the case it's like a header map, then the result of self, or some rejection. And it is that a rejection is an error. So if you have like a JSON extractor that parses the request body, well, what if the request you get is not JSON? It doesn't have the right content type, or the bytes are wrong, or it doesn't have the right field, so you can't deserialize into whatever type you want. Then that's effectively your error or rejection type, and that has to implement the intro response trait. And then Axum will make sure that if the extractor fails, then a response is returned and your handler is basically not called. So the sort of short circuits in that way. And this is part of what I mean by the predictable error handling model, because errors are basically not a thing. Like there's just responses. There's things that implement response or implement intro response. It doesn't really matter if your app calls it an error or not. In terms of Axum, it's just a response. Sort of all the same. So we saw an example of some extractors before. Method URI and header map obviously implement extractor. But Axum has a few more built in. Query is one that works with Serde's deserialize trait. So any type that implements deserialize, you can sort of parse that out of the query params in the URLs. So all those things that come after the question mark. Path is how you pull out path params. That also works with any deserializable type. In this case, we're saying that we want one path parameter. So that could be like /users/ID. Pull out the user ID, parse it into U32. And lastly, there's a JSON that works the same way. This syntax, I get questions about that sometimes, where you like to sort of destructure the value directly in the arguments. You can actually do pattern matching directly in function arguments in Rust, as long as it's an irrefutable pattern, I think is the word. And that works because JSON is just a tuple struct that has like one public field. So it's sort of like doing a match directly in the function arguments. That just means you don't have to say like .0 on the first line in the extractor. So it's just a little nicer. But how does that even work? Like I thought, like Rust doesn't have variatic functions. You can only have a fixed number of arguments. So how is that even possible? How can get work for functions that both take one argument, or 2 arguments, or like 8 arguments? How does that work? And the magic's all in this handler trait that we have. So handler has a single method called call that just takes a request and produces a response. And then it's generated over 2 types. T, we'll see that soon, is basically the inputs to the handler. And then B is the request body, which you don't need to worry too much about. So then we can implement this handler trait where T, so the inputs, is just an empty tuple. Because in this case, F is just a function that doesn't take any arguments. It returns a future, and the future's output implements into response. So then in order to go from a request to a response, we can just call self. So that's this function that gives us a future. We await it, and we call that into response. And then we have a response. For functions that take 1 argument, this is the magic comma up here that makes it all work. So this tells us that it's a tuple of 1 type. If you leave this comma out, then it's just type like a type with parentheses around it. So the parentheses are sort of redundant, so that's the same as a T1. But by putting the comma there, you avoid the conflicting trait implementations which you would otherwise get. And then it's basically the same thing. It's just this time F is a function that takes 1 argument of type T1 that implements from request, returns a future that can be converted into a response, and then we just kind of do what you would otherwise expect. We make one of these request parts, call from request on T1, we get back a T1 or a rejection that we have to return early, and at the very end we can call self, it takes a T1, await into response. Pretty straightforward stuff. And this scales as well. 2 arguments, 3 arguments, see where this is going. We have a little macro that we use to generate all these implementations internally. And way at the bottom, we have a higher order macro, basically, called all the tuples. That takes another macro and expands into this. So you're right, Rust does not have variatic functions, and Axum extractors only accept up to 16 arguments. If you want 17, I'm very curious what your use case is, but you're welcome to open an issue, and then we'll add one more line to this macro. Yeah, and in that case, get doesn't even know anything about functions. It just takes a thing that implements handler, and then it just needs to know how to box that effectively and erase the type. And then what you get back at the end is just a method of it, and all the generics are sort of gone. So this is how all this machinery works, basically. There's one shout out that I want to give, and that's a debug macro that we have in a crate called Axum macros, which are utility macros that you sometimes can use with Axum. So you don't have to use this, but unfortunately the type errors that you get are sort of horrible. From all these like many trait implementations, the Rust compilation is not good at generating error messages for that. So if you write something like this, we have a user struct with an ID, and then we try and use it with the JSON here. Rust is just like, this thing doesn't implement handler. And you're like, why? Why does it not implement handler? It looks like it should, right? If you slap this macro on there, the error message changes, and now it's like, user doesn't implement deserialize. And then you put derive deserialize up here, and then it works. So the only purpose of this macro is to improve the error messages from Rust. So it generates a whole bunch of code that basically have a bunch of trait bounds that we know that Rust understands, and give good error message for those trait bounds. But it doesn't actually change your code in any way. It's not too bad when you have these JSON types, but sometimes people will like hold a mutex lock across an await bound, and now their handler future is not send anymore. Axum requires that, and that's really subtle. So sometimes this macro is helpful. I even use it myself sometimes.
Sorry?
Yes.
And have you filed like a bug report on it?
Yes.
There is a
There's been an issue open before Axum even existed. There's a game engine called Bevy, which uses exactly the same technique, and that's where I got the idea for extractors. They have an entity component system where you can sort of parse components out of your game state or whatever. And they have the same problem, and they filed an issue. And I went into the issue, and I was like, hey, Axum has the same problem.
Yeah, because I saw the Bevy developers also making like a design issue recently about some of the things they want in their error messages, and I thought of this as well now.
Yep, we have the exact same problem. Actix uses the exact same pattern for extractors. They have the same problem. So unfortunately, not much we can do.
But do the other ones also have a similar debug thing?
Not that I know of. No. Cool, responses. So a handler function has to return anything that implements into response. We'll see that soon. Obviously, a response can be converted into response. That's sort of trivial. But writing these like builder type methods is just kind of tedious. It doesn't compose really well. So what you can actually do in Axum is just return a tuple of, in this case, a status code and some response body. And Axum then knows that it's a string, so you probably want the text plain content type. And then we just put the bytes in the response. And then we set the status code. Status code OK is the default. So you can actually just return a string that does the same. But if you put like not found or whatever, it would sort of override the default status code there. And the way that works is we have a trait called intro response. It just takes a self, so that will be the tuple in this case, and returns a response. And then we can implement that for strings. Just call the response builder that you saw in the original message before, or we can do it for a tuple, where the first one is a status code and the second one is an intro response. And we just convert the T into a response and override the status code from the first element of the tuple. Yes?
Why into response rather than using the int trait?
I don't have a good answer. I'm not sure if we would be able to write the kinds of implementations on the second half here for the into trait. I'm not sure that works for tuples because we don't own the tuple type, if you will. I also kind of like the symmetry of we have from request and into response. I think that sort of matches up nicely. If you want to add headers, you can return a tuple of 3 elements with a status code, headers in the middle, and then whatever response body in the middle, and all that will sort of get merged together. building a header map like this is a little bit verbose. You can just put an array of tuples with 2 elements in the middle. That works too. And then the first element, the x-foo, that's just the header name, and the second one is bar. And then in this case, Axum would convert the last one to a response, override the status code, and then merge all the headers together. Yes.
It's also implementing to response in JSON.
Yep. So the JSON type that we saw earlier as an extractor, that is also an intro response. You might be wondering, how does this machinery work with the 3 tuples? The original approach that we had in Axum was the top one here, where we just had an implementation for a tuple of 3 elements with a status code, header map, and a T. The problem with that is that if I want to write a library that can provide like high-level response parts effectively, so that I want to write a cookie library. Cookies are just headers, but I might want to have a cookie jar type that sort of behind the scenes gets converted into headers. You can't do that as a library author because like this implementation is baked into Axum. And you can't, as a library author, provide an intro response implementation where this type here is different. Because again, you don't own the tuple type. You might try to do the last thing here, where you're just like, hey, I accept the status code and 2 things that implement intro response. But then the problem is, what if your user does something like this? What's the response code now? Is it okay or is it not found? It's kind of not like, and what if you have multiple response bodies even? How does that work? So Axum actually has a second trait called intro response parts that takes one of these intro response parts things. It's very similar to response, but just has a constrained API. Returns back the response parts or some error that again implements intro response. And then response parts basically have these methods. You can only mutate the headers or the extensions. You don't need to worry too much about extensions. It's basically a thing to let you communicate state with middleware. But mainly what we care about is headers. And then we can implement this trait for a header map. That's straightforward. We just get immutable reference to headers and extend them with self. That's just calling the good old extend trait. And in this case, the error is infallible because it can never fail. And then Axum can then provide implementations for a tuple, where the first thing is an intro response parts. So we know it can't set the status code and it can't set the response body because you don't have access to those things. You can only set these things mutably. So that means that as a user, it's very easy to know what the status code will be in the end. And the implementation is very much what you'd expect. Obviously, we do that for tuples of 3 elements, and we have a macro that does it for tuples of up to 16. So if you want to compose lots of tuple responses together, you can totally do that. So there's a lot of machinery here. Like what actually implements intro response? Well, a tuple of T1 to Tn at most 16, where all these T's in front implement intro response parts, and the last one implements intro response. So that means that when you see one of these big tuples, there should be no question about what is the status code. Because if the first one is not a status code, you can see that implements intro response as well, then the status will be the one that's on the last element. It couldn't possibly be anyone else. You can also put a status code as the first element, and then up to 16 intro response parts things in the middle, and then an intro response at the very end. And this is what I mean when I say that you can sort of compose different response types together. So what's really cool and what's better than this version up here, and why this one is strictly better, is that all these types in the middle, like I mentioned before, it's an array here, but it could be a cookie jar type implemented in some third-party library. It just implements Axum's trait, and then it just magically works, and it just sort of sets headers. That's why this system, I think, is better because it composes much nicer. If you were to build the same thing with these builders, I don't even know yet, but you'd have to have methods that take a mutable reference to the response builder or something, but then they can change the body, which is kind of weird for a cookie library to do. I don't even know. So yeah, I definitely think the last version is nicer. Cool, so putting all the things together. We make a router, we add a route to /sessions, and that will do like some session login sort of stuff in the website. We have an integration to a library maintained by the team that also makes Hyper called headers, which are basically type-safe HTTP headers. They provide a header called authorization, and then type header will then turn authorization into an extractor. So this is basically a a sort of typed way to extract the authorization header. Axum Extra, which is another crate that has additional utility type for Axum, has one of these cookie jar things that I mentioned before. And cookie jar implements both from request, so that'll parse the cookie header in the request, and it also implements into response parts, where it'll set the set cookie header on the response. And then result, I didn't show that here, but result also implements into response if both types inside also implement into response. And this is what I mean when I say that Axum has a simple and predictable error handling model. Because errors are not a thing. It's just a response. Axum doesn't care about errors. As long as your error can be converted into a response, go for it. And then you can write whatever domain logic you want in the middle, add a cookie jar. Obviously, you have to return the cookie jar back out because it needs to set headers on the response to tell the browser, hey, there's a new cookie. And redirect is a type that implements into response that sets a 3.0 something status code and a location header. Then you get a redirect. Otherwise, you return an unauthorized status code. So this is sort of composing all the different pieces together.
Question?
Yes.
What does redirect to implement a part or a?
It implements the whole one into response.
Right.
Because it needs to set the status code.
Yeah.
Yes. And that also means that you can't accidentally have redirect twice in these tuples. That wouldn't touch it. Yeah. Here's another example. Extension. Like I mentioned before, extensions is just sort of a way to dependency inject arbitrary types effectively. So here we're injecting a database pool or whatever. You have to add that in via middleware. Unfortunately, there's no type-safe connection between these two. So Axum won't complain if you try to extract an extension that you didn't add a corresponding middleware for. If you can figure out how to fix that in a not super inconvenient way, then please make a pull request, because I don't know how to do it. Path, we saw before, that just extracts the path parameter up here, in this case as an UID. JSON gives you parts of the request body as some deserializable type. We do our domain at logic in the middle and return again a JSON at the very end to get the updated user serialize the JSON with the right content type. Yes?
What if you, on this user's update, also wanted to put a constraint that it should only be allowed to happen if the user is logged in, for example?
Then you would probably make an extractor called current user or logged in or whatever. And then in the from request implementation for that type, you would check that the header is there and try to find them in the database or do whatever you want. And then if that one succeeds, then you just return it, and then you would get that here, just like you get path and JSON. But if the user is not logged in or you can't find them in the database or whatever, then you return a rejection. And then your handler would not be called, and you would effectively short circuit.
But there's a way to say that all paths beneath / logged in, for example, or beneath / admin, there could be maybe 10 different logs.
Yeah,
But
then you would use a middleware.
need to have that.
Then you would use a middleware.
Okay, and maybe
We're
we're going to talk
gonna
about that. Okay, great.
Cool. Well, a middleware is just any sort of function or whatever that can transform the request in some way, call the next thing, whatever in your application. Maybe that's another middleware, maybe it's the handler itself, we don't really know. All we know is that we get back a response at the end, which we can then change and then return it back out if we want to. And Axum is sort of built to take advantage of Tower and Tower HTTP, which is an ecosystem of middleware. So if you go to the Axum repo itself, there's no, at least very few middleware that are built into Axum, because all the ones that work or are into Tower HTTP also work with Axum. But Tower HTTP is not specific to Axum, so if you have another framework that also supports Tower, you can technically use our middleware stuff. That means that you get stuff like tracing, timeouts, compression, request ID cores, and tons of other middleware for free, basically, that the community have all contributed. The way that you add a middleware is you call .layer. So a layer is not a middleware. It's like a function that applies a middleware to a service. You don't need to worry too much about it, but if you want the timeout middleware, you use the timeout layer. You say, hey, timeout after 30 seconds. I also want a very permissive cores set up for if I'm doing like front-end JavaScript stuff that needs to call my API, and I will also like tracing. And then all these middlewares will sort of get wrapped around your application, and that fits together nicely. All these like methods that we saw before to sort of compose routers also work with middleware. So in this case, we just have the example that we saw before, where we have one router that has a timeout. This will apply the layer to all routes applied above. So in this case, it's only /foo. But if I did like another route at the end here, that would not get the timeout middleware. When you call .layer, it applies to any route you've added previously. That's great if you have a lot of routes that you want the middleware to have. If you're like, I only want this one route to have a layer, you can just say .layer on whatever thing get returns. If you're like, I want to accept both get and post, but only post should have the middleware, you can do that too. So there's really deep integration with basically anywhere that you think you can put a middleware, you can put a middleware there. And then you can merge them all together at the end, and then for the sort of combination of all of these routes, apply tracing around the whole thing. So what you would do in your case is you would write your own tower service layer thing that does your session login or whatever you want.
And you could use that for other stuff that releases tower,
Yes.
not necessarily just this framework.
Exactly. You can implement your own middleware. Hard mode is definitely implementing the service trait itself. This is in Tower. I'm not going to talk about it today. I give a talk like at every other of these meetups, and I think I show the service trait every time. And every time I say I'm not going to talk about it, so maybe my next talk I should actually talk about it. If you just want to like write a middleware for your application and you don't intend to share it in the library, I recommend that you use Axum middleware from event. One of the reasons that the service trait is annoying is that we don't really have async traits, really. We have the async trait macro that kind of cheats by boxing things. But this from event is basically a little helper that allows you to write a middleware as just a regular async function. So it has to take a request and this next thing. So next is just the next step in your middleware chain, basically. And then you can just do whatever you want to the request. You can call next or not if you don't want to. If maybe your authorization failed, get back a response, do whatever you want to the response, and then return it at the very end. And then you can say layer, middleware from event, and give it your function. And then Axum sort of figures out how to convert this function with this exact signature into a tower service. So if you're going to write your own middleware in your own application, this is how I recommend it, because it's just way easier. Yes.
So what if you want the database handle somewhere in there? How do you feed it?
Currently, whoops. Oh my God, I went currently, there is API to run extractors directly in this middleware. So if you have a database extension extractor or whatever that injects your database that you use in all your other handlers, you can use that in your middleware too. In the next version of Axum, you'll be able to put extractors up here, and they will just magically work. So that if you have such a database dependency injection extractor, instead of writing, well, you have to write request if you want to call next, but you could just, between these two top lines, you could just write what you would write in a handler function. So like extension, database, and then the extension.
That was for next version.
Yes, but today there is an API to call extractors in here. I don't have an example. I can show you later. Yeah. You can do it. It's a little inconvenient. You have to know that there are two types in the docs that kind of work together in this way. It's definitely possible, and it's a use case that we do support. But in the next version of Axum, all the boilerplate goes away, basically. So here's an example of that. A very simple tracing middleware. When the request comes in, we start a timer, grab the method in the URI, call the next thing, who knows what it is, we know we get a response back, and we're like, how long did that take? And then we just log a tracing event, and then we return the response out. And this is a middleware, and you just use it with from event, and that works. Doing it this way is just so much easier than implementing the service trait. If you want to learn more, I recommend you look at the docs. I've sort of realized that the reason that you write docs for your APIs is so that when people ask, you have something to link to, because people don't read it. Like you can write all the docs in the world, people are not going to read them. But we have a lot of docs. I spend a lot of time writing docs. The repo is here. You're welcome to ask questions there as well. As of last week, I think we have 43 examples in the repo, and there's everything from OAuth to a chat web server with WebSockets and all kinds of different things. We have a file called ecosystem.md, which is just a place that people can dump links to things they've made that use Axum. Either it's a project that's open source, or it's a crate they made, it's like some library, whatever. So there's a bunch of cool libraries in there that are related to Axum. And if you have any questions, I effectively live in the Axum channel on the Tokyo Discord. I just have it open all day while I'm working, and I usually answer questions all the time there. If you're ever stuck, hop in the Discord. That was all I wanted to say. So, are there any questions? Yes.
Open API when?
When we released Axum back in July of last week, the same day there was an issue open for like, hey, I would like Open API. My stance currently is that I don't have time to build it. It's also not something that I personally have a need for at work, and I'm a bit reluctant to build stuff that I don't need, because then I have a hard time sort of evaluating it. I have made prototypes for a way to do it with Axum that doesn't require anything built into Axum itself. It's entirely its own separate library. Technically, that means that I don't have to build it. You could build it. So I can sort of flip the question around and be like, when do you build it?
So you like that prototype? Like last time there, I saw the issues and stuff for it, and I saw you had a GitHub repository or a crate, but there was like nothing there.
I have opened, I believe, 2 pull requests to Axum. And I'm like, here's a prototype, and then 2 weeks later, I'm like, I don't have time to finish it. I close it. I can definitely send you those links. It's Open API is a thing that I would very much want. I just personally don't have time to build it myself.
What is Open API?
It's like an API specification saying that you have these and these paths, and on these and these paths there are these gets and posts, and they take these parameters and they return these types as JSON or XML or whatever.
So it's like an API specification language thing.
Yeah, basically, yeah. Then you can take those files, and there are a bunch of different language generators for them, so you can spit out a JavaScript client or C# client.
Generalized Swagger or something.
It is Swagger.
It is
It
Swagger.
is.
It's the standardized version of Swagger.
When is the next version of Axum?
The next like patch release or the next major?
One that has that.
So summer is coming up now, and the person who reviews all my pull requests to Axum is going on vacation. I am going on vacation, so sometime after summer.
Before Christmas.
I don't make any promises. Sometime after summer. There's a bunch of open issues for sort of long-standing problems that we really want to take a hard think about and try to actually solve some of the issues and the sort of footguns that are in the API that require making breaking changes. So I don't release new breaking versions willy-nilly. But it's in the works. We actually, since I think on Monday, I merged the first like breaking PRs and actually started open source services. So it's coming.
A while ago, you presented Axum Live and Tokyo Console something demo app. You made any more progress on that?
Well, the repo is open source, so yeah. Nope, not yet, unfortunately. I wish.
So Rust is still a known language, and you have a lot of different web frameworks currently. Do you see this field converging to anyone in particular?
Ooh. No, I don't, and I'm not sure it should. I have there's many things in Axum that I have stolen from other frameworks because they had a good idea. Like the from event middleware thing that we saw, I stole that from another framework called Poem. I was like, that's awesome. That totally makes sense. We should just do that rather than making services themselves. But I think there's a lot of cross-pollination back and forth. So
why create a new one and not just adapt the other ones to your use case?
So the sort of initial seed for Axum was what if we have a middleware, what if we have a framework that's just tower service all the way down? And to make that kind of architecture with any of the existing frameworks was not really feasible. Warp has its own thing like filter. If we change that to use service instead, it's not really Warp anymore. Actix is stable and they have their own service trait that's an old version of towers, so we can't really change that either. So the only option we really had was to make our own.
What's like the next thing you're excited to put in, ignoring the time constraints?
We've actually since last week I think found an issue or a solution to a long-standing problem we've had since day one effectively, where if you put two JSON extractors or like two extractors in a handler that both take the body from the request, that fails. But you don't get a compile error. It just fails at runtime because the body is an async stream. And you can only consume that once. We found a type-safe way to fix that at compile time, basically. And I wrote the PR for it last weekend, I think. I was super stoked when I wrote that. I was like, whoa, we've had this bug for, well, not bug, but like footnote for a year. So finding like small eureka moments like that is what I really enjoy. But as far as like API-wise, I don't imagine that the overall like shape of Axum API will change much, really.
Do you know if there are any RFCs or whatever they're called in Rust to add variatic arguments to functions at compile time?
I would be surprised if it's not something that people have requested. I don't know if there's any plans or any accepted RFCs.
I don't think so.
I think
It's also not
really
a hard.
Yeah, like there are ways to work around it, as you saw.
I mean, yeah, there's very C macro feelings.
Well, I mean, yeah, but they're sort of hidden away. Like I write the macros. You as a user don't write any macros. That's the trade-off. I write macros, and you don't have to.
Yeah, and you don't actually need the macros, right? So the trait hierarchy thing is.
I could write all the code by hand. You're right.
Yeah, but I'm talking about having them automated in the same way that lets you compile fast and get good error messages out of it because the compiler understands that this is a list of arguments.
Yeah, but like if you want good error messages, does that require Variatics? Maybe not. Maybe we could just improve the error messages with what we have now. I'm not sure. I've used languages that have Variatics and not, and I don't really personally have an opinion about it. So
I think that if you want good error messages when you're faking Variatics by using macro expansions, you need Variatics in the same way.
I don't know. I'm not a language designer. Maybe.
But it's more like faking it with traits rather than. So the macros just use the way you generate the trait instances. But so the variant stuff is more like a trait thing.
It's just from like a compilation perspective, instead of just saying, hey, this is my function that can take n arguments, and then when you instantiate it as a user, you get like the 3 instantiates of that function. You're not instantiating 16 versions of that function, generating code, compiling all that, and turning it all away.
Right.
It just makes it harder to get to where you want to be.
I don't think there's any code in the binary for this 16 case, because if there's no function that actually has 16 arguments, then the trait doesn't exist at runtime basically. So the code is not there unless you use it.
Yeah, no, I know it won't be in the binary. Like even if it was compiled, it would be thrown away by any good linker.
Yeah.
But just in terms of like.
No, not even. It's not thrown away by the linker. It's a template that never gets instantiated.
Yeah, I mean, even if it was compiled. Yeah, it was just a curiosity.
Are there any languages that have Variatics where they don't all have to be the same type?
D?
I looked at D. Because that's what we need. We don't need n strings. We need n arguments of different types.
So D gives you a list that you can ask the size, access as an array, you can query the type, and all sorts of introspection.
If it's an array, can it be different types?
It's not a real array, you have array-like access to it.
But it's a compile time.
It's a compile time thing. It's like the best feature of D that nothing else has. And that's the thing that I miss about D. The rest is just kind of
Time to write an RFC to write.
Exactly. Sounds like you're passionate about this.
Just use C Variatics.
Yeah, because that solves all the problems.
That's just so
Way
annoying.
Oh, you know what kind of questions I usually ask? So I saw that there was a reference to Tokyo on the very first slide, and there were 2 namespace references in Tokyo. Would this be possible to use with another async runtime? I assume it's pretty tied to Tokyo.
So
I'm also trying to get evicted from the premises.
So when I say that Axum is built on Tokyo, that's actually a lie, because I think that often backend people who come to Rust for the first time, the library that they look for is a web framework. So I want it to be very approachable for beginners. So if I write in the README that it supports any async runtime that supports Tower, that sort of confuses people. If I just say it works with Tokyo, that works. But you're totally right. Axum doesn't know anything about Tokyo.
Oh, so
Hyper
it can
is
be run on Orange.
yes. Hyper also can be run without Tokyo. When you make a server builder, there's an executor method, and that just takes an executor which implements a trait that has a single method to spawn a future. And it has a default implementation that uses Tokyo, but technically Hyper and by extension also Axum does actually not require Tokyo. Well, not the Tokyo runtime. They require like the async read and write traits on those things, but the schedule on those things, no. I don't know that there's anyone that runs Axum on not Tokyo.
No, but
In theory, it's possible.
If you need the Tokyo read and write traits, and you're in the Tokyo ecosystem anyway.
I know there are people that use Hyper without Tokyo. I think Fuchsia at Google, I think they do that. I think they use Hyper but not Tokyo. I think Sean, the maintainer of Hyper, has to talk about it. Yeah. Well, that was my last slide. Thank you.